Well, again, I have chosen this platform to teach something about light. So, of course, light is form of energy. Everyone knows it. But as of some of my dear relatives, and they have their child in 9th class, 10th class. For them, I'm just giving this by which they can easily get access of it directly because it's for me it's not always easy to make things very planned. Of course, I'll save it. It will remain for everyone. In light, if we'll talk of some basic things, of course, it helps us to see things. When you are in dark room, then nobody can see you. Why that is? Because there is no light on you. But if you are in dark room and one is in light shade or outside of your room where there is light, where there is sunlight, then of course you can see him or her. Why that is? Because once light falls onto you, then it reflects back. Some portions may get absorbed. There are other things, but fundamentally, I must talk you. Light has some properties. Light is a light has some energy. Light is an electromagnetic wave because if you will go for electromagnetic wave for lower classes, it's not important, but there is whole spectrum when sun releases its rays that contains cosmic rays, gamma rays, X rays, UV rays, visible rays, infrared, radio wave. All those waves have their uses, but light particularly because whatever we do, we means one cannot do anything in dark. So when you are doing in light, then you need to understand the concept of light. So the fundamental things which light follows as a rule, light has some reflection property, light has some refraction property. So in reflection also there are two laws. Means it's like very technical. If I'll go, may I sketch those lines and everything. I have one book also where I can directly share to you, and on that I can go through. Okay, these portions I'm talking of, these things I'm talking of. But to be very honest, before that, there you must have some preface of light. So if you know this, that yeah, light can be reflected, but from where it will be reflected. So without going to chalk and talk, only talk if I'll do, then there must be a surface where light will incident, and that should not be a transparent one. Then there is chance it will reflect back. But for that, there are things like what kind of media from where light is coming, and what kind of media where on which it is hitting, and what is below that media. Like if we'll take a glass full of water and you will dip pencil into it, you will see that okay, the shades of pencil or the shadow of pencil is not as such as if will kept in a empty glass. That means there is something which is happening. That phenomena is refraction. But I'm sharing this just to give you idea. Okay, the performance of light becomes different in different media. So when if we'll talk of okay, there is something black, like may you have heard of black holes. What does really it means? Something like something goes, does not come out for right now. So in refraction, where it is used for refraction means how that refraction for what region one should know refraction also. If reflection is fine, okay, on object it is falling, it is coming back to us, so, then okay. And there is due to that reflection law, we are able to see that. But where reflection is helping in lenses, you see, when we have issues with our eyesights, like we don't have that 6 by 6 perfection, then doctor just they suggest us to have lenses. Okay, the lenses maybe it's a convex lens or a concave lens, depends on of what kind of problem you are having, whether you cannot see the objects which are very nearer to you or it is far from you. So on those phenomena, there is an instrument which will help you to monitor what kind of power you require. Power means in light, power means related to focus, means what kind of focal shift your eye has. Means again now it will be very technical. So to keep in short, light is a form of energy. light help us to see the objects. Light has some certain laws, that is the law of reflection, law of refraction. And then there will there we will see then after we will see something for which I am sharing. I'm willing to share you my screen, which may help you, and I hope it will be. Yeah, I think it's a chapter, and I have this chapter from this book is of ICSE, and the chapter's heading itself is reflection of light. Means particular portion we are reading, that is reflection of light. So in reflection, what you will read, of course, images formed by a pair of parallel and perpendicular plane mirrors. You know, wherever there is image, at least there should be a two rays which should come and interact at some point. When they will meet, then only the image will be formed. So in this chapter, what means author has described, or this book covers, is key laws of reflection. As I mentioned you, there are few laws which means light follows, and experimental verification. Then of course characteristics of images formed in a pair of mirror, parallel and perpendicular of each other. Uses of plane mirrors. So then we'll go for spherical mirrors. Of course, in our homes, we use regularly mirrors. So just because we had to keep this length very short. So laws of reflection, if you'll see, the return of light into the same media after striking a surface is called reflection. So reflection phenomena is very obvious. It reflects back. Means when it will hit to somewhere, it will get reflected. So kind of reflection, maybe regular reflection, of course rough reflection. From regular reflection, that is plane. Plane is a very smooth one. Then for it, where it is hitting, so from that will be a particular point. But let's say there is a road, a village road, means kind of patches, full of patches. So from that full of patches, when light will go, some will hit to the top surface, some will go to the depth, or that way. So by this way, you can understand what is regular reflection, what is irregular reflection. So plane mirror is the best example to visualize what is regular reflection, and irregular, of course, one know. So I would focus on reflection from plane mirror. So there is light. You see, if there is light, that means incident ray. I think I must take the advantage of this also, because I can do annotation on it, and I can open things for you. And here it is. Here it is. My book. And then of course I think reflection of light. Yeah. And I think now, yes, because it will be easier for me to scroll or something here. Now you see, I can do annotation. It's an incident. I'm talking about this incident ray. Once it comes in, it hits to the surface. This is surface. This is interface. I must say this is interface. Means two faces are interacting on this particular plane line. So this is polished one. So you have to form a perpendicular line, or on that point just put a normal on it. Normal means a perpendicular line on the plane on which it is incidenting. So once it incident there is some angle which is measured. This is incident angle. This is your incident angle. Although in books everything is given, but I must tell you this is incident angle, and from where it will reflect, that angle has to measure from that same normal. That will be reflected angle. So there is relation. Once you will go, then there is law. What is law? Law is angle of incidence will be equal to angle of reflection. So laws of reflection, you see, angle of incidence is equal to, I'm talking about of this line. I hope it's very clear to you. Angle I is equal to angle R. What is angle I? Angle I is angle of incidence. What is angle R? Angle R is angle of reflection. There is one law, and there is second thing. That laws of reflection, one is angle I is equal to R, that is angle of incidence is equal to angle of reflection. The incident ray, the reflected ray, and the normal at that point of incidence lie in same plane. This is very important. You see this second law. For this second law, I must tell you this figure will give you more visualization. All these three, this one, the incident one, the normal one, and the reflected one. They must lie in same plane. If it is a plane, all three lines, they must be in same plane. This, and this. All three should be in same plane. That is what that holds another law of reflection. Okay, the incident ray, the reflected ray, and the normal at that point of incidence lie in same plane. Once it is fine for you, then angle of reflection, I have told you, that is measured from normal one. This one I'm talking about, plane of incidence, on which plane it is incidenting, and of course angle of incidence, that is your projected angle, what angle it is making when it is hitting to the surface. So this particular eye I am talking of. Now for me, next if I'll talk of, then experimental verification. Of course one can do it. You just need to keep a plane mirror. You need to just pinpoint there, and you see the best way. There is plane mirror. You need to have a cardboard. You just keep your mirror there. You just put a pinpoint there. You will see from another end there will be a reflection. So you just wherever you are seeing in that line's reflection, you put your pin again there. And by this way, you put the another pin in the same line, and then you will see when you will match that point, that pin which you have just made before, the another pin will have another point. But when you will meet them, that and line will be formed, because for making line you must have 2 points. So two pins there from the angle of incidence side, means from where you are just projecting your ray, and after from that normal, the another 2 points which you will just connect, then there will be a line. So there is one line of 2 points of projection, and the another which after reflection you are visualizing from your eye. This is beautifully eye made to make you realize, and this is normal angle. You will see, you just need to measure this. You will find the angle I is equal to R. This is what this we call one of the law. You can prove it, and of course these all three lines are in same. These all three lines are in same plane. Sorry, and there was a call. And types of image. Of course, a real image. That means, what is real image? On a screen which is formed, that is image which can be obtained on a screen, is real image. What is virtual image? Cannot be obtained, like behind a screen, है ना? If you are seeing yourself, then the image which you are seeing, it's not you, but of course it is your image. So that is your virtual image. So that's what a very important line. It is sorry, a very important line. Just a minute. It is formed when light rays after reflection do not actually intersect. Okay, it seems like intersecting, but they do not intersect. So there is here a real intersection will be there. Then it will form a real image. But in that case, that will be a virtual image. So a real image formed due to actual intersection, and that will form due to virtual intersection. Means it will be like they are meeting, but actually they are not meeting. So image on extended object formed by a plane mirror. You see one of the example. You just put here mirror. You just keep these two objects. You will see at back side of mirror you find yourself. Even if you see yourself, you will find that at back side of the mirror you are there. So that's your virtual image. Okay. So of course, by this way, I must go ahead because I have to just compile those things for you. So position of image, really it is very important. You can see when you will be very far from your mirror. So then you will see your image of a smaller size. And the second thing, it will be not be clearer to you. The closer you will come, the closer your image will come, and you will have a better clarity. There is condition. If you want to see your full face, then your mirror size should be half of it. Then at a particular focal point, you can find your full image. So there is condition. As in my previous live class, I was like, science is totally logical. Science, one can measure things, one can validate things. So that is why I'm saying you, if one want to see his full length in mirror, then the size of the mirror should be half when he is at a certain point. So there it becomes very important. What is your position when you are looking yourself into the mirror? Lateral inversion, a very good point. I must tell you, that the interchange of left and right sides, if the image of an object in a plane mirror is called lateral, you see something you write. I feel like the best way, you write on your pocket something and you just go in mirror, you will see the inversion of it. If it is spherical, it will not be observed. But if it is later, of course, you will visualize, okay, the things has been changed. So there are means very good. If you know reflection, if you know loss, then anything you can sort out. A student, for a student, those students who have read triangles, here it will be very helpful from where that angle is formed, what is alternate angle, what is corresponding angle. So there here it is of much appreciation that for reading anything, if you are reading physics, how the maths helps you. If you are reading maths, how the physical concept can give you real world examples. So anyway, characteristics of the image formed by a plane mirror. You can see here are the two images one can see, and at the back, A dash B dash point is there. Let's say one person is there here in this image, and his reflection is A dash at the back side. Similarly, if he's there at point B, you will see B dash. Yeah, similarly, what nowadays people are doing, you are getting selfies. So when you stand at front of mirror, you see if you are ahead, you are at front of them. Means you are the first one backside to the mirror. If somebody stands besides you, then another image gets created of that same person besides you on that backside. So similarly, if A is there, A dash will be there. If B is there, B dash will be there. So that's fantastic. And now you just please read these questions, examples, authors put their heads to make you feel, make you visualize how one can understand the concepts, because it's not like, yeah, I'm just teaching you and you will get to know this all. No, it means it will take time. So please make sure that whenever I'm in live now, next time, if you have any kind of question, please put your things into the comments key where you require time for from my side to put things slowly, because it's just like I'm covering this. Okay, how one can look, what are the importance of light, what are the basic laws, what is plane mirror, what is incident ray, what is reflected ray, what is angle of incidence, what is angle of reflection, what are two laws of light, how image is formed, what is virtual image, what is real image. Means although I'm very fast now, but because I'm running short of my time, so next time I will just, if whatever things you will put for me, I will make sure that I will take time, and in those, or whatever the points I have covered, in those I will be selecting one and I will be teaching it for 10 to 15 minutes, provided I have that enough time. Huh? So that's all the objective question you can go for. You will appreciate it. And then the next topic they have given, I can't cover it, but I hope that if you have a book, you can go through, you can ask me, or you can select the topic. Of course, it will be very interesting for me. Spherical mirrors, you see, even in your cars, and I mean, so many places you can go through that there are the mirrors, there are two structures, concave, convex. So how it is formed, so what is the region, like I said initially, in even in your eyes, when there is lenses, here we are talking about one surface is polished, but in lenses what is there are two curvatures which are not polished, but they help in forming image. So they help in focusing images. So those mirrors, those lenses, they are very important to your life. I hope you will just read this sometimes, and then I will come back. Of course, then there is a very smart point. In light, there must be something like a plane on which you are keeping your objects, your focal point, your focal plane, your center of curvature, and where your image is formed, that particular point. So all that V, U, F will come into picture, where we will be virtual image, you will be in the position of your image, and of course F will be your focal length. So means one cannot cover in a one day, because light is really interesting. If I'll make this all in a particular, means in this 5 to 10 minutes, then you may get bored, because light is a subject which really need to be taught with race, which really need to be taught with a passion, that one should, unless they visualize it, we should not go to the next. Because if I say that image can be formed by having an interaction of two rays, then you must understand it why that particular line or statement has been made, that two rays when they intersect from means after reflection, then there will be a image formation by mirror. Or if you will, then they will not be really intersecting, that at least they will be virtually meeting at the another end, that what we called as virtual image. So for that image formation, you need to put means put things by rays, and I must be means I must also have some time to make those things clear to you. So anyways, uh, the lights, you see there are means conditions, 5 to 6 conditions for which the mirror will have a real image, virtual image, erected image, you know, and that inverted image, all this, microscopy, you see, as a biologist, there are two lenses. So here it will come mathematical formulation that will really give you, very interesting feeling. Oh, those all things which we were talking quantitatively, now it will be measured, now everything will be formed into a formula, everything will be set, and those all, even the values or sign convention will give you a physical meaning. We'll discuss sometime later. And then of course magnification, you may have gone through some, like mirrors in museums. They have a different kind of reflection, elongation, means even your mobile cameras, they are giving you n number of multiple options to enhance your faces or length. They elongate it on one way or another way. So very interesting. So all those mirror concepts, convex, concave, it means may I someday, may means I, if I'll get, of course I will be happy to teach you all. You see those exercise and all. I think this book is available on internet also, freely. So if you can go through, then it will be a final job for me. Then only I will feel like okay, I have taught you something. So so this is from my side, and I hope ki you will, I mean, after those in those last 5 to 7 minutes I was in hurry, but before that whatever I talk to you, you can just go back in my live class, or you can just scroll back. So at least you will have the fundamentally where, for what reason we should learn light. And for a student of ninth or 10th, and they must be very clear कि light has also some principal rules, or that is what we call laws. Even in reflection there are two laws. Later on in 10th or onwards we will read refraction. There will also be a two laws, Snell's law and all. But for right now, if those laws are there, that means every time in all cases, it will be valid. Means there is no such case where you can prove it wrong. So think in that way कि, okay, if I will understand for once, forever I will understand other concepts, or it will help me in just bridging from starting end to the application, like telescope or anything. Means you will see that cameras, digital cameras, snapshots, like this, say कि, okay, 35 mm, this whatever now you used to get, numbers on your mobile cameras or digital cameras, you will be really amazed कि, okay, I can have that understanding कि, okay, what is focal length, okay, what is position, like why a cameraman used to say, come closer to you, used to go far from you, or why they say okay, come into picture. Aperture size, focal length, radius, means curvature, or curvature, the size of curvature, although that depends on which company is forming for, means what application they are making their lenses. But of course those all terms are really relevant to you. Your focal length, if you will understand, you will understand कि, okay, that is the point where rays will meet. And then in later on you will get to know कि, okay, what is plus zero point 0.5 power, what is minus zero point 0.5 power, or minus 0.75 power. Means that values and sign will tell you कि, okay, means what actually he's suffering, means how close he cannot see, how close he can see. Those all two things will be very clear. How far he can see, how far he cannot see. That power lens, that numbers will give you that idea. So once you will start knowing this all in small segments, then up to that you will connect it. But let's say कि It means you will act like a way that okay, light is there or rays are there, and it's a clumsy one. I can't get, I can't make those figures. I can't put that rays. Means it has to pass from focal point, and you are passing it through, radius of curvature. So that will be very messy. Like you won't get that virtual or real image feeling. So for those all like erected image, once when will erected image will be formed. So what is a role of when the object will be placed between that focal point to the pole. If one is object has been kept between the focal length and the pole, what kind of image will be formed? And the other way key that if it is beyond the focal length, then what kind of image will be formed? I want to say you that it's all about your learning capability, but it means I have read it, so I'm just explaining in a 20 to 25 minute. Be a slow learner, but be a conceptual learner. You just make yourself engaged. Okay, if applications are there, how that is made means what a camera company thinks of. Okay, the good digital photo has to take. Then what kind of focal precision or means what is role of focus point or focus size? Like if it is written 35 mm, 65 mm, then you must know okay that micro lens. Why we are saying micro lens? Why four lenses they are coupling together? Means they are coupled, and then the overall image you get it from how the real concept of making image transform into making video. What is difference between video and image? Means beautiful things. Really sorry my dears that today I have to go now because I'm getting my calls, but someday I will be live again and I will connect you all, and I hope that I will for sure make you feel one should read light not for your syllabus but for getting those applications. Because if you will be a good if you want to be a good engineer or doctor, then everywhere even in spectroscopy as a doctor, all the diagnosis tools you see, one see x-ray and they say okay, there are the hairline fracture and there is fracture. So that visualization how will make how that prints come to you. Like a doctor, can only a doctor predict that okay there is hairline fracture? Why you can't? Then that's another advanced stage. And similarly for engineer, key light okay reflection is there, diamond is more shining than your gold. Why it is so? Then you will say total internal reflection. Means a number of phenomena are there. Now we are saying okay, now Indradhanus are not formed in India. The climatic change is there. Why Indradhanus were formed? What kind of Indradhanus is there? On what principle Indradhanus is formed? Then you will see okay, scattering of light. You will see the clouds are there, accumulation is there. Means you believe me that there are applications, but you have to give your time. So thanks for all who are watching me. And it's my second class where I have gone live, but I hope I will get times in weekends or at least twice in a month. So that's all from my side. Have a good day to you all. Thank you.